Hello. Hi. Thanks, Karan, for that wonderful introduction. And I'm Viral Shah. I'm one of the creators of the Julia programming language and also co-founder and CEO of Julia Computing. I'm going to talk about how we build Julia and our community out in the open, a lot of it mostly on GitHub. And everything I'm going to talk about is not just about me, but about what the broader Julia community has built. So Julia has been a long journey. It's been around for almost 11 years now. And we started this journey in 2009 with an urge to solve the two-language problem. The two-language problem, very simply put, is a phrase that we coined actually after starting the Julia project. And the reason why we had to come up with it was because it was hard to explain why the world needed a new programming language. Why did the world need Julia? And the reason is as follows, right? Everyone's used to programming with Python, with R, with MATLAB, with all of these interpreted languages that are, not really great for performance. But then you always end up writing your programs in C, C++, Fortran, Java in order to get higher performance. So people like to have a certain kind of language for data exploration, for interactive exploration, for for just sort of interacting with your algorithms, and then another language for getting performance. And it's really odd to write the same program twice. And this is why we started out by creating Julia to solve this two-language problem so that you can have the ease of Python and the speed of C all in one package, in one language. So in 2009, we wrote the first line of code. And in 2012, we actually published a blog post called Why We Created Julia. If you Google that term, you'll land up right there and you'll see what it was about. And a lot of what we wrote back then still holds true. And this is how Julia got started. It was the four of us with Jeff Bezanson, Stefan Karpinski, and Alan Edelman. Those were three of my co-creators with whom I started the Julia project. And just like many open source projects, it completely started out with an email conversation. I was actually based out of Bangalore when I started this project, and three of my collaborators were based out of the US, but all of us were in very different geographies. And it was a completely distributed setup in where we started, talking by email, set up a Git server. This was not yet on GitHub back then. We actually had a Git server at the University of California at Santa Barbara that Stefan used to maintain. And very early on in the project's life, we actually ended up moving to GitHub. Some of the other milestones for the project: Julia became the JU in Jupyter in 2013, the second language that was added to Jupyter. For those of you who do not know this, Jupyter notebooks are extremely common for data science, and they stand for Julia, Python, and R. And so Julia is the JU in Jupyter. In 2015, we actually founded Julia Computing because of all the interest around the Julia programming language. And some of the first companies started using Julia commercially. We hit 1 million downloads in 2017. 1.0 was released in 2018 in JuliaCon in London. And 2019 saw 10 million Julia downloads. We were extremely thrilled to receive the Wilkinson Prize for our contributions to Julia, and also the Sidney Fernbach Prize last year, was a couple of years ago now. And we are now close to 25 million downloads. And even though my slide says Julia 1.5 released, in fact, yesterday we just released Julia 1.6. It has been getting rave reviews. It was trending on Hacker News just about yesterday, and it's obviously the best release of Julia ever so far. So while Julia as a programming language solved the two-language problem for scientists and engineers, it really is making impact in the real world. People are using Julia for faster drug development. Companies like Pfizer and Moderna are using Julia to come up with new drugs and take them through the drug pipeline process in a faster way. Companies like Mitsubishi Electric are working with us, Mitsubishi Electric Research Labs, on energy efficient buildings and air conditioning systems. With Julia, we are able to simulate some of these air conditioning systems 500 times faster than was possible before. And that means that a year's worth of simulation of how an air conditioning system might react to all the changes in in temperature and weather and so on and so forth can now be done in a few days because of Julia. We're working with a team at Carnegie Mellon with Professor Venkat Vishwanathan on coming up with new and efficient batteries, like the kinds that go into electric aircraft, coming up with new materials for these batteries and new simulation technologies for sort of putting batteries into new electric aircraft hardware. Or, there's a lot of work by the Climate Machine project between MIT and Caltech, where Julia and its scientific machine learning ecosystem are being used for climate science and climate modeling and its impact on agriculture and on just a number of many different applications. So these are some really difficult scientific problems that Julia is addressing today. And what I'm going to talk about is the journey from developing the Julia language, developing a community, building out Julia computing, and then being able to actually work on some of these cutting edge problems. So here's the Julia project on GitHub. It's, just a JuliaLang / Julia. JuliaLang is the organization, Julia is the project. It has 33,000 stars and tons and tons of commits. Yeah, there you go, close to 50,000 commits. And all these many forks. So it is a living, breathing project with over 1,100 contributors to the main Julia project. I don't like this little red checkbox here, as anyone who's been on GitHub likes it. This is a screenshot that I just took before this talk. But we work very hard to make our CI green, but this CI is very demanding. We actually run our own CI systems that test every commit of Julia on 32-bit, 64-bit Intel, ARM, and all sorts of architectures on Windows, Mac, Linux. So it is a difficult CI to pass, but we take it very seriously. As I said, we released 1.6 just a couple of days ago. One of the things I wanted to do for this talk was dig back into my own first commit out of into Julia, and it turns out that was in September of 2009, where we had where my first commit was actually to add some of the array operations into Julia, and it's just all looks so different. I mean, we didn't even have .jl extensions back then; they were .j, and then you can sort of see how the project's going. We added the plus method right there, implemented addition for double scalars, and we're off to the races. One of the things I like to highlight about Julia is that we started out, I personally started out my work and my contributions to Julia in India, and I wrote a majority of my Julia code out of India for the first several years. This is a picture of many of the early contributors to Julia from JuliaCon India 2015. And we wish to be able to do more JuliaCons in India going forward, but this is a small team that got started. Indian open source contributors have had an outsized impact on the Julia language. Apart from some of the people I have here, I should also mention that contributors from India are a part of the Google Summer of Code project. Every year, at least anywhere between 1/3 and 1/2 of the contributors that we mentor in the Google Summer of Code program are actually out of Indian universities. And so it's not only sort of people contributing to Julia from the industry, but we have a lot of people from Indian universities, undergraduates, especially, that are contributing to Julia. And the community has seen exponential growth. It has been, we've seen 25 million downloads so far. They've been compounding year on year. Tons and tons of YouTube views. Check out Alan Edelman's computational thinking class, computationalthinking.mit.edu, which I think is the best way to learn Julia and some of the scientific machine learning examples that I showed before. We have a forum views on, we use Discourse for our forums. The number of news articles, the number of Julia packages, 5,000 Julia packages today. And it has been a phenomenal journey. Not only can you call these 5,000 packages from Julia, but you can also call every Python and R package and every C and Fortran library, every Java library ever written. So often people ask me that, hey, it's a new language and maybe it doesn't have enough packages. And I say, not only can we call the 5,000 packages in Julia, but just about everything else. And especially Python packages are a breeze to call, Python and R packages. You pretty much do not have to do any boilerplate to call them. Julia has now entered the mainstream. We were number 19 on IEEE spectrum, and in 2020 we went from 47 to 23 on the TIOB index. Some of these indexes are very noisy, but directionally Julia has been doing really well on many measures of popularity of programming languages, as flawed as they all are. I think they do sort of paint a long-term picture. My personal estimate is that the Julia community is over 1 million users now worldwide. We've seen downloads from over 10,000 companies from at Julia Computing. You're seeing it being used and taught at over 1,500 universities, including some of the best ones out there. And here's some of the universities that are actually teaching and using Julia. There's over 100 GitHub organizations, and this is unique about Julia, I think, compared to many open source languages, because Julia was developed on GitHub from a very early stage. And so the GitHub community structure matches and maps to GitHub organizations. It's just something that has been built up organically over time. And you can look at this, right? There's a climate org, there's a EcoJulia, which is for ecology. FluxML is our machine learning organization. Julia Actions is where a lot of our CI work, and the GitHub Actions are held, or Julia Berry for Raspberry Pi, or JuliaLang here, for example, for probabilistic programming. Julia Images for image processing. So these are just fantastic organizations that we've been seeing people put up, and I just love all the logos that people have come up with, which are sort of based on the Julia logo itself and the colors and the theme. How fast is Julia? It is really fast. This is the benchmark that is on the computer language benchmarks came on Debian. Julia is in the top 5 with C, Rust, in Fortran. You have Julia right up there. And really fast with graph processing, with basic data science, machine learning, loading CSV files turns out to be really fast in Julia because of multi-threading. And some of our data frames benchmarks also show Julia comparing very well with some very optimized tools like Spark and Pandas. So Julia is fast, but don't take my word for it. Try it out yourself. There's a growing collection of Julia books out there that have been all contributed by the community. Many of these are from professors at Stanford, especially linear algebra and optimization are 2 of my favorite books. I would highly recommend looking at some of these books. These are beautifully produced books. But then at the other extreme, we have a book by Ahan Sen-Gupta, which is the little book of Julia algorithms for kids to learn Julia. And we've seen kids as young as 10 years old learning Julia from that book. One of the most interesting things about Julia, I think, is in terms of user experiences, is Pluto notebooks. Of course, Visual Studio Code has now become the IDE of choice for Julia users, but Pluto notebooks have been developed by Fons Vanderpla from Amsterdam, and this is a reactive lightweight notebook. So Jupyter is a general purpose notebook environment that is language agnostic, whereas Pluto is a Julia specific notebook, which means that it's reactive. When you update a cell out there, it will automatically update the calculations in all the other cells. I would highly recommend checking out the JuliaCon 2020 talk by Fons. I would also point out that JuliaCon 2021 is coming up very soon. It's going to be at the end of July. Sign up at juliacon.org. Signups are free, and the conference is online this year. So all this is great. Now, how do we go from building a community, building out Julia, to sort of solving all those interesting problems that I talked about, right? Problems that the world is facing, problems in climate, and problems in combating a pandemic, or how do you cool your houses when the weather keeps heating up or the climate keeps heating up. Machine learning is a major part of this, and what Julia does fantastically compared to many of the other programming languages is that it takes machine learning to the next level by integrating it deeply into the language, concept that we refer to as differentiable programming. And the way this all works out is as follows, right? Everyone's familiar with machine learning, enormous data sets, distributed computing, lots of new hardware, got to run on Raspberry Pis, got to run on Androids. But what really makes it all happen is automatic differentiation, the ability to differentiate your programs, not just your neural networks and do backpropagation, but can I do back propagation through my entire Julia programs, through my solvers, through my optimization routines, through, through just about everything, right? Through differential equation solvers and so on and so forth. And that is, this basic idea is at the crux of all of Julia's SciML ecosystem. And it's possible because Julia's machine learning libraries have been natively written in Julia itself. So for example, if you look at PyTorch or TensorFlow, there's tons of CUDA and C, but Julia's machine learning libraries are written in native Julia itself. Here's Julia GPU. So Julia also runs natively on GPUs, and this is just these are benchmarks compared to CUDA C. As you can see, they're almost as fast, in some cases faster than CUDA C, and some cases a little bit slower. But native GPU programming in Julia is essential for the Julia machine learning ecosystem and the scientific machine learning ecosystem in Julia. It's being used for tons of interesting projects. I would love to call out a project by Jonathan Laurent from Carnegie Mellon University, called AlphaZero.jl, which is AlphaZero implemented in just a few hundred, maybe a couple of thousands of lines of Julia. And hear more about it at JuliaCon, or download the package and try it out. So all of this comes together, the GPU capabilities, the Flux machine learning capabilities, and just about everything in Julia comes together in, with what we call differentiable programming. And what Julia offers is language-wide differentiable programming, which means that not only with your neural networks, but any arbitrary Julia code is amenable to differentiation, which means it's amenable to be put into a machine learning loop. It's amenable to stochastic gradient descent and optimization. And this is something that scientists and engineers around the world are combining. They're taking Julia's traditional machine learning capabilities and deep learning capabilities like the Flux library, and combining that with all the scientific and machine learning and image processing and data processing and differential equation libraries together, so that you can apply some of these ideas into just about every Julia program ever written, and combine your data-driven machine learning that comes out of deep learning with model-driven scientific learning, and sort of get the best of both worlds. I would highly recommend looking at Chris Rakakis's talks online, where he talks about, he's the author of Julia's scientific machine learning ecosystem, and he talks about all these different applications. If you just look him up on YouTube, applications in pharmaceuticals, in engineering, in chemistry, in manufacturing, in batteries, in climate. This is how the ecosystem comes together. And this is why I personally believe that a programming language can really change the world. It's all built by the Julia community. It builds up one foundation, builds up from the foundation one step at a time, and goes up all the way to solving amazing and interesting problems out there. What do we do at Julia Computing? I'd like to sort of leave you guys with a small advertisement about JuliaHub. JuliaHub is a platform that is built to provide the best Julia experience, where you can explore, build, run, scale, and visualize your Julia programs. You get online VS Code editing, along with scaling Julia programs to large numbers of GPUs and CPUs on the cloud, and all these amazing workflows right from the Julia language and the Julia compiler, the thousands of libraries, all the machine learning ecosystem, the scientific machine learning tools, the parallelization, the GPU computing, all the way up to solving some of these problems. These entire ecosystems are being put together on JuliaHub, so that they're available to everyone from students to scientists at some of the best companies out there. At just put it all on their fingertips. That's what JuliaHub enables. So I would urge you all to try it out. Try it out at JuliaHub.com and let us know what your experience is out there. Come join the Julia community on GitHub, and I'm going to be talking on the discussions right after my talk. Thank you very much.
Wow. Okay, that was Viral Shah, who gave such a nice overview of Julia. Hey Viral, we're just having a little bit of an early Holi celebration out here. So all of these colors and confetti is what you can see. But thanks a lot. That was a really nice session about Julia, and we have quite some questions coming in. So the first thing, Viral, that the developers want to know is Julia being an open source programming language, as well as where you have a business. So how does Julia Computing build an open source business?
That's a very good question, actually, and one that I often get. That what's open source and what's not, and how does an open source company make money? And we are committed to the open source community. That's what created Julia, and the company exists to sort of leverage the community, add to the community, and just sort of grow the community going forward. So the way we do it is that all of Julia is open source, the language, the compiler, the ecosystem, and we are major contributors to it. All the co-creators of the Julia language are co-founders of Julia Computing, and we have the best interests of the communities at heart. What we like to do for our business, for our customers, is build a cloud-based software as a service product, which is JuliaHub, which is what was my last slide. And we expect that by providing JuliaHub on the cloud to all the Julia users out there in enterprises and around the world, is how we'll build a successful business. And these are very well aligned incentives, because this means that there is not going to, it's not an open core model. It's not that optimization level -03 is only available by Julia Computing to its customers, but that everything out there is in the open source, is in the open domain, and the company actually integrates it into our cloud service for enterprise users.
So I love that Julia is open source,
yeah.
But where can someone go and learn more about Julia? Are there like online courses, or is there anything that you can point us to?
Well,
yes,
for someone
so there's if you go to JuliaLang.org, which is the Julia website, or if you just Google Julia, instead of getting actresses named Julia, you nowadays get the Julia language, especially if you're a programmer on the Google top hit. So if you go to the Julia website, there's a learning section, and we also have JuliaAcademy.com, which are free online courses for getting started with Julia, in addition to all the books that I mentioned. But the Julia learning, the learning page on JuliaLang.org puts everything together for learning.
That is Viral. That's going to be probably my favorite sentence for the day that you said, like when you go on the search engine and search for Julia, instead of actresses, you'll find the open source programming language. That's really my best quote for today, So that's really great. So coming back, there's one more question. So if you had to do, one thing differently building the Julia programming language today, what would you have done?
Yeah, that's a very hard question, actually. What would we have done differently if we were to build Julia today, right? And I mean, it's hard to say, right? Because had we taken a slightly different path, would things have been different in some way? To be honest, it's all about the community and the journey, and that's sort of far more interesting than any sort of technical decision around the language itself. If anything, I think what I would love to see happen in Julia is some of the decisions that if you were to start out now, there are just so many more mature open source language frameworks that we can use today that were not available when we started in 2009. LLVM had just come out back then, and it was not what it is today, but it has definitely been difficult for us working with LLVM and seeing sort of some of the challenges and so on and so forth. So we might do a few things differently today. It's not clear what exactly would they be, but I guess one of the things I would say is that I would work for even deeper integration of some of the machine learning tools that we talked about during my talk, and they would become even more first class as part of the Julia language than they are today, given just how important some of these technologies are.
Nice. So you mentioned, I like how you mentioned, it's more about the community and the journey. So where can someone go and then interact with the Julia community, find peers, or find someone really to help them grow in their journey in learning the language and kind of like exploring it to its depth?
Yeah. So again, on JuliaLang.org, you have the community section, which has all the community pointers. We use Discourse for our mailing list and discussion forums. So discourse.julialang.org is a very vibrant community out there. We also have the JuliaLang Slack, which has over 5,000 people on it, and it's just insane. So that's a good way for interactive communication. But a lot of our community interactions also happen on GitHub, because if you post in a GitHub comment and someone replies to you, it's almost like chat. It happens in real time, and a lot of those communications actually get archived and are crawlable by Google, and someone else can come a few months later, a year later, join into the discussion. So there's many different forums for people. There's chat, there's mailing lists, there's GitHub. And all of them are phenomenal. Also, Julia packages are all 100% on GitHub. Well, maybe not 100%, but definitely 99% on GitHub. And all of them have their own issue trackers on GitHub as well. So I would say that if you're engaging with the community, there's the language, but then there's also all the packages, and a lot of people end up often working on the packages. One of the things we've done over the last few years is actually made it easy for people to do things in packages rather than in core Julia itself, and sort of make it easy to extend Julia. And that's where we see a lot of discussion actually moving into packages going forward.
Great.
Thanks so much,
so
Viral.
awesome.
That was fantastic. Everyone head on over to GitHub Discussions. Viral's going to be there for the next 30 minutes to continue answering your questions. And you can post your questions at GitHub Satellite/discussions. See you later, Viral.
Thank you.
Thanks, Viral. See you.
Bye. See you on the discussions.